Hi, I'm Mr. V, and let's talk about notation for a moment. If I have a point A and I move to point B, I can do that by saying I start at A and I go along directed line segment from A to B. This is a vector. It has an X component, so this would be my change in X, and it has a Y component. This is my change in Y. So I could say I'm going to start at A, and I'll add to it the directed line segment, delta x to delta y, and I write this as a vector in brackets, and this will take me all the way to B. What if instead I didn't want to go all the way? I want to divide this segment up and go 15/16 of the way, or 3/5 of the way. Or let's choose 2/3 of the way because it's going to end up being a nice number on the grid, and it'll do for my illustration purposes. Let's call this point P. So if I do A and I add to it 2/3 of this directed line segment of the change in X, the change in X and the change in Y. I'll write it as in brackets because it's a movement, it's a change, not just a coordinate. This should take me to P. Now A, our point here, has the coordinates of 3, 3. B has the coordinates of 9, 6. And P, we can look on this grid. It's nice and pretty and easy, but it could be any point. Depending on which points I use, it could be any point. This will have the points 7, 5, the coordinates. Now, if what I'm saying is true, then this should take us to 7, 5. So let's try it. We start off at 3, 3, and we're going to add to it a portion of the directed line segment. So we're not going to do all of the change in the X direction and all of the change in the Y. This is 6 and this is 3. And to find that, one way to find that would be to take my two coordinates here from A and B. So I have 3, 3, and 9, 6. What is my change in the X direction? This would be plus 6. This would be plus 3. So we know that the change, the delta X and delta Y, and we can find that from the two endpoints. You take the place you're going to, you subtract from it the one that you started from to get the delta X, and same to get the delta Y. Now this should get us to point P, and let's just check and see if it is going to be 7.5. So I have 3, 3, and to that I'm going to add 2 times 6 is 12/3 and 6/3. Well, this is 3 plus 3, 3, 3, and we're going to add to it 4. This is a vector notation, 4 and 2. And when we do that, we end up at the point 4 plus 3 is 7, 2 plus 3 is 5. So you can see how this notation of a vector works. And more importantly, this one, where I can take some fraction of that to get a fraction of the distance along the line. Good luck and success.